Hello and welcome to TN Academy. For our question today, we have the following diagram which shows two buildings situated on level ground. Now from point P on the ground directly between the two buildings, we have the angle of elevation to the top of the buildings, which is given by theta. Now, the distance from point P to point A at the top of the building, on the taller building, is 150 meters. And the distance from point P to point B at the top of the building of the shorter building is 90 meters. Okay. And the distance between point A and B is 154 meters. Now, for our first question, A, we're asked to find the measure of APB. Now, to do this, one of the rules we can use is the cosine rule. Now, for the cosine rule, we can say that a squared is equal to b squared plus c squared minus 2bc times cos of a, where cos of a would represent the angle, the cos of the angle APB, which we are looking for, and a would be the line from A would be the line from point A to B. Just a little oopsie there. B would be the line from A to P. Point C would be the line from P to B, which would be 90 meters. And again, A is the line from point A to B, which is 154 meters. Yeah. And so when we substitute this in our equation, we should get 154 squared is equal to 150 squared plus 90 squared minus 2 times BC, which is 150, 90, and then times cos of A, the angle we're looking for. And we can rearrange all of this, of course, to solve for cos of APB, which would then be, we took some steps to do this, like subtracting 150 squared and 90 squared from both sides, as well as dividing by -2 times 150 times 90. Should get the following. Squared divided by 2. We should get this. And when we simplify, our expression be the following, where we get -6,884 divided by -27,000, which is just equal to 0.25496. And then we can take the inverse cos of our left side to find our angle. Which is 75.2 degrees, or 1.31298, 1.31 radians if you're working in radians. And that is our answer to question 1. Now for question one, question A. Now for question B, we are asked to find the height of the taller building, which is here, h. And we can do this by finding theta and then finding the sine of that theta, as well as multiplying by a value. Now we'll see this visually. So when we look at our graph, you can see that these two thetas are equivalent, and our angle APB plus the two thetas add up to 180. So another way that we can think of this is that 180 is equal to our angle APB plus 2 theta. And so if we rewrite this to isolate for theta, then we can say that 180 minus APB divided by 2 will give us our angle theta. And when we substitute our angle in, we'll get the following, and we can calculate for theta, which should come out to be 52.3856 degrees. And if you did this in radians, you would instead subtract your previously found value in radians from pi 1.31 with all the extra wonderful digits, and find your answer to be 941,302. Okay, and then as mentioned, with this angle, we know that sine theta is simply equal to the height divided by our hypotenuse, which is 150, or, since we're solving for the height, of course, we would say that 150 times sine of our angle will give us the height, the value that we're searching for. And when you plug that all into your calculator, you should find your answer to be 118.82 meters, which we can round up to approximate to 119 meters. And that is your answer for part B, and all the answers for this question.